Why does Soundaware have this situation? Everyone knows. Our investigation shows it's about this motherboard, the only 100 motherboard. Then this is the A300's motherboard where the decoding section is located. And then the Damonis motherboard with its analog and digital sections. So looking at this, I can tell you all directly, I found some audiophiles who feel that the 700 model still has an advantage, meaning more people choose this motherboard than that one. But this is Soundaware's first generation motherboard, designed in 2011. This one was designed in 2019. A difference of nearly 10 years. Yet the result is that few say, hey, I choose this one. So why has Soundaware from O100, A200, A200, 80, A300 to Damoni undergone such massive changes each time? Let me analyze it for you. Analyze it. Do you know what the problem is with this motherboard? First, don't think. Here's an objective fact for you. Don't think, oh, this motherboard must be very expensive. I tell you, the production cost of this motherboard is just a few hundred RMB. Because the only 100, its price, this thing includes this motherboard plus a case and buttons. Its selling price is less than 3,000 RMB. Therefore, however expensive this motherboard is, it cannot be above 800 RMB. It's impossible for the production material cost to be lower than 800 RMB. So comparing these two, you discover a big problem. What audiophile C does not represent the real thing? Oh, it'll tell you something very, very objective. Everyone knows these materials look like premium stuff. Dell capacitors, Philips capacitors with high perceived prices. But in 2010, 2011, 2012, I can tell you their prices were very low. Inside the things like Elna capacitors, I tell you these small capacity capacitors cost just a few mil, even a few fan. Take this Siemens film capacitor 100 NF type. Do you know how much it costs? We can buy 1,000 for 100 RMB. So its intrinsic price is actually very low. How many Dale resistors are used? Just a few each, costing only a few mil. Used how many? So its overall production cost isn't actually high. This is one point. It looks impressive because of its op-amps. Look at these two. The others are all 5,532. These two can be swapped for 2,604. They ended up using 2,604, mainly for higher sound clarity. The others are all 5,532. Do you know how much a 5,532 costs? Just a few mil. So I can tell you, including its transistors. Look at its transistors. Its power transistors are LM317s. How much did an LM317 cost back then? 1 or 2 RMB. Therefore, every component looks expensive, but none actually was expensive. Back then, the materials appear piled high, but at the time, not a single one was particularly costly or premium. The only component possibly exceeding 10 RMB might be the 2,604, but they only used 2 of them. Basically, every other component was under 10 RMB, single-digit RMB. That's why the price could be relatively low produced for just a few hundred RMB. The 8,852 DAC chip, the 8,852, its op-amp might cost over 10 RMB. So its price isn't actually high either. The production cost of this motherboard is relatively low. Then why did Soundaware abandon this piled high looking design? Audiophiles might not understand why is your transistor only costing 1 RMB? Why is this transistor inside costing over 20 RMB? Why is that transistor costing over 20 RMB? One is a power transistor. It's also 15A. It's actually 2 channels of 15A because it's 47 MV noise. These old ones are in the tens of millivolts range. Tens of millivolts. Of course, there's a difference. Both are 15AO. So I tell you all, the material grades are not on the same level which people can't see. Look at this. The material grade. Look, just one transistor. You see it's very, very small. But one costing dozens of RMB. How many are used? 1, 2, 3, 4. Just for the main power supply. Those 4 parts handle 8 channels, not to mention others. Therefore, why was this abandoned? Because with this type of material and component usage, even with rich experience, the sound still cannot achieve the effect of a high-end DAC. I can tell you it's acceptable for entry level, okay, no problem. For mid to high-end, impossible. It's decided by the material grade. That's why this sounds worse than the A200, worse than the A280. That's the reason the sound of the A200, A280 isn't like this. They use higher grade materials, but they have very few through-hole components. Like the A300, you see hardly any through-hole components besides a few on the main power supply. Look, almost none, all surface mount. Now finally, the second reason, well, the first reason for abandoning the old design was that its materials weren't actually very high grade, not considered high grade at the time. This is the first and most important point. I just said, it looks like it's piled high with components, but its design was quite reasonable for those materials. It was very well designed within those constraints. The second point I want to make is about why Soundaware gradually abandoned this material approach. The first reason is around 2013, 2014, the hi-fi industry started changing. Hi-fi manufacturers began changing factories, meaning material consistency became very poor. What does that mean? Take ulnar capacitors. I can tell you, even different versions sound different. Even with the same bill of material, BOM, the same ulnar theatrical series, or some ulnar series, each production batch might sound different. If we continue with this solution, it causes a huge problem. The RN800 produced in 2012 versus the RN800 produced in 2013. I tell you, it sounded different, completely different. Because with so many components, if any few change in sound character, the overall sound changes. Therefore, consistency became Soundaware's biggest problem. The Damoni 15th anniversary, I can tell you, has extremely high consistency, very consistent sound. But this motherboard R100 type, I tell you, its consistency was poor. Every year, even each batch I bought might be inconsistent. If I got the wrong batch, its consistency was very poor. The reason for abandoning it is the very poor consistency. It was hard to achieve high consistency. This is the first reason. It's suppliers. Because we buy materials from suppliers and these suppliers changed a lot, consistency was very poor. The second problem is, look at all through-hole components. It's not that through-hole components are necessarily better than SMD or SMD better than through-hole. That statement is meaningless. But using all through-hole, these are all through-hole components. You don't see a single SMD part. Even the resistors are through-hole. What's the difference between an SMD resistor and a through-hole resistor for common types like this? No significant difference, I tell you. No significant difference. So, in this situation, why use through-hole resistors? That's what needs thinking about. Using high-end ones like Dell might be slightly better than some SMD, but for ordinary ones, why use through-hole resistors? It's excessive. Using all through-hole resistors creates a big problem. Know what it is. It increases the signal path length, which is detrimental to specifications, detail, and noise. Very detrimental. Therefore, through-hole materials should be used in moderation. My point is moderation because going all through-hole leads to significantly longer paths you have to wind around. Due to the larger volume, it loops around. Nowadays, whether analog or digital circuits, the trend is miniaturization, extreme miniaturization. One main aspect of miniaturization is improved material precision. The second aspect is that the overall layout signal quality can actually be improved. It can be done better. This is the second most important reason, meaning once we move towards miniaturization and high precision, through-hole components were basically abandoned wherever possible, keeping only a few key ones for tuning, because there are many methods for tuning. This second reason is also why specifications saw a significant improvement. Therefore, these two reasons led Soundaware when designing new solutions to shift towards polymers. Here, pointing likely to newer boards because polymers have better specs than these aluminum electrolytics. That's the second reason for the change in capacitor type. So the first reason, huge changes in audio material suppliers year by year led to very poor production. Consistency significant sound changes, some spec variations. The first and second, as just said, all through hole lengthens the entire path because the volume is fixed here. It gets longer. So it leads to degraded signal quality, worse specs. The second, third reason is actually related to the second. What does it mean? Look, if it's only an analog DAC USB input, then output, basically all analog, then all through hole might be somewhat acceptable. But if placed inside a digital player streamer, where there's a big interference source, this all-through-hole circuit is susceptible to interference. Understand? It's easily disturbed. Look at my A300. Look at the A300's board. This material, all SMD. I can easily put a shield over it. Shielding is very easy. But this old board, to shoot it, it have to wrap the whole thing, which is very difficult to shoot effectively. It's easily disturbed. All-through-hole makes it susceptible to interference. Points 2 and 3 are essentially the same issue. The signal path isn't optimal. Don't use all through hole. Using some individually is fine. Through hole is okay. But using all through hole when SMD is available. Using all through hole isn't a good thing. The most important point is the last point, the ultimate point. What is it? Audio materials. Why did so many companies making them go out of business? They vanished. Look here. Look at this one. See my Dun 100 Pro, its capacitors use WIMA black box. Do you know how much a WIMA black box cost in 2013 47 UF? Was only about 20-something RMB each. Do you know now 500-600, 300-400 RMB prices like that? Meaning audio materials are basically all discontinued. Now you can't buy them even if you want to. Soundaware actually started transitioning in 2013. By 2014, we were rarely using them anymore. Because audio material manufacturers were unstable. Each batch was different. I tell you, Elna changed factories. Malaysia factory, then another, some Japanese factory, then finally became Shanghai, domestic Jiahua. Production, the factories kept changing and the sound changed with each factory change. Look at Philips early. Philips' original factory later changed to Philips BC production. They had a 136 KO model. Completely different sound, not an audio capacitor sound at all. The 136 KO was originally designed as an audio capacitor. Therefore, these materials basically disappeared. They are just leftover stock, impossible for normal mass production. So, another reason is that this situation became apparent as early as 2013. Now, basically, there are no real audio materials left, or they aren't what people imagine. I can tell you for certain Elna models, the factory changed 4 or 5 times. Each factory's production sounded different. So this became meaningless. Audio materials are actually becoming less significant for many people. For the whole hi-fi industry, their significance is diminishing. Look at our Darmone, a reference grade DAC. How many audio materials does it use? Only 2. The whole thing uses just 2 audio materials. One is that ERO, MKP material. This was leftover stock I had. The other is an Elna, a specific version. Because the volume isn't huge, Demon maxes out at a few thousand units. I could buy out the entire batch at once to guarantee consistency. If the volume were larger, it wouldn't be possible. So it actually uses only 2 audio materials, no other audio materials. The rest are not audio materials. They are all industrial grade or RF class materials. Therefore, I tell you, all the technological changes now are extremely vast. Downfield DACs with an old mindset. View our hi-fi RD. Our hi-fi is now moving towards direct relevance with high-end instrumentation and RF technology. Look at Weiss professional DACs, look at Prism Sound professional DACs, or look at other high-end professional DACs. What do they use? Just a few components touched by audio. Generally speaking, it's basically gone. They all use RF and the high-end instrumentation materials. These are very high-end materials within the consumer industrial sphere, because the performance of these materials is much stronger than those audio ones. For example, in the Darmone, the filter capacitors, we have single capacitors with 8 mole internal resistance. Look, expecting an electrolytic capacitor to achieve 8 mole is impossible, and it's 100 kHz type. Look at its LDOs. They achieve 47 MV noise, 15A 47 MV 8 channels. Think about it. This was impossible before. Go back 10 years, you couldn't even buy them. Honestly, look at 2011, 2013, such materials didn't exist. Look at the Down 100 Pro back then. It also used high-grade materials, LT series LDOs for the Down 100 Pro. In 2013, we started using the top LT series, used 3 or 4 LT parts. They were around 30 MV, I tell you, 30 mil V, 15A. But the Damona directly achieves 47 NV 8 channels, 15A. So this technological change is enormous. It's because of the miniaturization of power supply materials driven by huge advancements in other non-audio industries, which in turn drove a massive improvement in hi-fi. Combined with rich experience, it can bring about a huge leap in hi-fi quality. Look at our Disconi now. Honestly, the Disconi Custom Edition seems to have just one capacitor that looks like an industry hi-fi material. Not a single material is a hi-fi material, but its musicality is good. The sound is very nice. And it's film capacitors. You think film capacitors are audio film capacitors? No. Its film capacitors are all instrumentation grade film capacitors, RF film capacitors. They are film capacitors. But as soon as you label them hi-fi, the price jumps to dozens of RMB. But if I buy them labeled for instrumentation, maybe 5 RMB is enough, 3 RMB is enough. Their performance is the same. As long as they don't sound harsh and we can tune with high-end consumer industrial instrumentation and RF materials to achieve very musical sound. Therefore, this requires a lot of experience, capability, and accumulation to achieve this effect. Alright, this reveals the final answer. Thank you all. Thanks.